Hello and welcome. In this video, we're going to do activity 11.3, which is a chi-square test of independence or association. So this is one where we have two separate variables and we're looking at frequency counts for those two variables. In this case, the example is that we're looking at whether or not people's political identification as Republican or Democrat is associated with their opinion on universal health care. And so we have asked people, in this case, they've asked college-age voters if they think it's the responsibility of the government to ensure that all Americans have health care. So they either said yes or no, so their opinion's yes or no there, and their political affiliation is recorded as either Republican or Democrat. All right, so to run this chi-square, we are going to click on frequencies, and we're looking at the test of association for independent samples here. Okay. Now what we're testing is to see if there's a relationship or an association between people's political affiliation and their opinion on universal health care. I'm going to move one of the variables into the rows box and the other into the opinion or into the column box. It doesn't matter which is which. Under statistics, I'm going to click on V in Kramer's V. And under cells, I'm clicking on expected counts. Okay. All right, now what we have here is we have in the very top table our expected frequencies or our expected counts, as well as our observed or the obtained ones we got from our study, those counts as well. The expected counts are what would be expected if the null hypothesis is true and there's actually no relationship between people's political affiliation and their opinion on health care. Okay. Now, if I look at my chi-square, I can see that the p is very low, which tells us, well, the data are different than the null, which means that there's a real association between, or probably anyway, a real association between political affiliation and their opinion on health care. And then I'm going to look at my data to interpret that. Now, for Democrats, I can see that they were more likely to say yes to that question about health care than would be expected if the null is true. Republicans were more likely to say no than would be expected if the null is true. You could have also interpreted this in terms of looking at Democrats were less likely to say no than would be expected if the null is true. Republicans were less likely to say yes than would be expected if the null is true. Either one is okay. Now, when we look at the very last table here, we have our estimates of effect size. We have a phi coefficient and Kramer's V, which are identical for a small design like this, which is a 2x2 design. Okay. Now, when we're looking at interpreting whether or not this is a small, medium, or large effect, we're using cut values or guidelines of about 0.1 for small, about 0.3 for medium, and about 0.5 for large. So in this case, it's about a medium effect. Now, if you had a bigger design, there are different cut values, so be sure to check the book for those guidelines on interpreting small, medium, and large effects with larger chi-square designs. Okay, and that should be all you need to run the analyses for a test of association. I hope that helps.